Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to solve the shear force and bending moment diagram. Draw shear force and bending moment diagram for simply supported beam with uniformly distributed load as shown in figure. In this question, we will draw shear force drawing and bending moment drawing. First, we will draw free body diagram of the given support. Second one, we will use equilibrium condition to find RA and RB value. This is RA, this is RB. Third, we will calculate shear force. Fourth one, we will calculate bending moment. Fifth one, we will draw shear force drawing based on the shear force calculation. Sixth one, we will draw bending moment drawing based on the bending moment calculation. First, we will draw free body diagram of the given support. You see here, this is UDL load. So we will convert into point load. So how we will convert this one? This is UDL. UDL distance is given as 2 meter. This UDL load is 2 kilonewton per meter. UDL into distance. Distance is DE. This distance. So UDL is given as 2 kilonewton per meter into DE is 2 meter. Meter cancel. 2 2s are 4. 4 kilonewton is the point load. We know the point load. What distance we will draw the point load? The formula is B by 2. B is the distance. UDL distance is 2 meter. 2 divided by 2 is equal to 1 meter. So this distance is given as 2 meter. So we will take center. So this distance is 1 meter. This distance is 1 meter. This is D. This is E. C. This is F. A to C distance is 1 meter. C to D distance is 1 meter. E to F distance is 1 meter. F to B distance is 1 meter. This is 1 kilonewton. Here is 4 kilonewton. Here is 4 kilonewton. Next, we will calculate RA and RB. To find RA and RB, we will use equilibrium condition. What are the equilibrium condition? Is the summation of f of x equal to 0. You see this graph, x is in horizontal, y is in vertical. So horizontal is this side. You see any horizontal force is there? No, right? Only vertical only is there, up and down vertical. So f of x is equal to 0. Neglect f. Next, we'll go for summation of f of y is equal to 0. You see this graph, y is in vertical. We will take arrows goes up is positive. RA, this is RB. You see the RA reaction force arrow goes up. You see up is positive. We will write RA. You see this load, arrow comes down. So down is negative, negative 1. Next, you see the arrow comes down only, is negative 4. Next arrow also comes down only. Next also negative 4. Next you see arrow goes up. Up is positive. Plus RB is equal to 0. RA plus RB is equal to, add this 3. 4 plus 4, 8. 8 plus 1, 9. So 9. Next we will calculate summation of moment A is equal to 0. Summation of moment A is equal to 0 is clockwise. We will take it as positive. Summation of moment A. So point A is here. If you have applied moment in the point A, that force should be 0. What is the moment formula? Moment is force into distance. Force is RA. Distance is 0. So RA into 0 is equal to 0. The distance of point A is 0. The moment also 0 for this point A. So RA into 0. Next, you see the arrow comes down. So down means you can see it goes clockwise. So clockwise is positive. Positive 1 into distance is 1 meter plus 1 into 1. Next we'll go this force. Force is 4 kilonewton. You see the arrow comes down. From here to here you see clockwise. Clockwise is positive 4. What is the distance? Perpendicular distance is from here to here. So here is 1, 2, 3 into 3. Next, we will see this force. This force also clockwise. You see the arrow comes down. Plus 4. What is the perpendicular distance in this? From here to here we will calculate. So what is the distance? Distance is 5. Next we will take this force. You see the arrow goes up. Up is, you see, from here to here, it's anti-clockwise. Anti-clockwise is negative. Minus RB into, what is the perpendicular distance from here to here? You can take 6 equal to 0. Next, RA into 0 is 0 plus 1 plus 4 3s are 12 plus 4 5s are 20 minus 6 RB is equal to 0. Next, add this 3. 20 plus 12 is 32. 32 plus 1 is 33. 33 minus 6 RB is equal to 0. Minus 6 RB is equal to minus 33. Minus minus cancel. RB is equal to 33 divided by 6 equal to 5.5 kilonewton. Now we got RB value is 5.5 kilonewton. Now we got RB value. We will substitute this value here. RA plus RB value is 5.5 equal to 9. RA is equal to 9 minus 5.5 equal to 3.5 kilonewton RA value. Now we got RA value is 3.5 kilonewton. RB value is 5.5 kilonewton. Next we will calculate shear force. Shear force calculation. We will see two rules for shear force calculation. First rule, the arrow goes up is positive, arrow comes down is positive. This is left side, this is right side. This is positive shear force. Next we will see second rule. Arrow comes down is negative, arrow goes up is negative. This is negative shear force. Based on this only we will calculate shear force. First we will calculate shear force between A and C. Now we will calculate shear force between A and C. You see here A is also point load, C is also point load. So we will take shear force between A and C. We will draw the line here. This side is left side, this whole side is right side. Now we will take left side. A arrow goes up. Up is positive, down is negative. We will see only left side. Plus RA value is 3.5 kilonewton. Or now we will calculate right side. You see the arrow comes down. Arrow comes down is, you see, positive. Plus 1. Next you see arrow comes down only. Down is positive for right side. Plus 4. Next you see arrow comes down only, so plus 4. Next you see the arrow goes up. So up is negative. So negative 5.5. Now we will add this 3. 4 plus 4, 8. 8 plus 1, 9. 9 minus 5.5. So 9 minus 5.5 is 3.5 kilonewton. What is the shear force definition? Algebraic sum of the vertical force acting on the left or right of the cut section along the span of the beam. We will calculate left side and right side also, but the answer should be same for both the sides. Next, we will calculate shear force between C and D. Now we will calculate shear force between C and D. So we will draw the line. From this side to this side is left side. So from here to this side is right side. Now we will calculate left side. Left side, you see the arrow goes up. Up is positive. Plus RA value is 3.5. Next, you see the arrow comes down. Down is minus 1. Up to here only we will calculate left side. So what comes? 3.5 minus 1 is 2.5 kilonewton. Or now we will calculate right side. You see this arrow comes down. Right side arrow comes down is positive 4. Next, you see the arrow comes down. Right side is positive plus 4. You see this one, the arrow goes up. Right side up is negative. Negative 5.5. What is the answer? 8 minus 5.5 equal to 2.5 kilonewton. You see right side and left side answer is same only. Next, we will calculate shear force at D point. C to D. D to E is UDL. So we will calculate D point only. From D point to A, this is left side. D to B is right side. Now we will calculate left side. RA is goes up. RA, you see the arrow goes up. Left side is goes up is plus. Plus 3.5. Next, you see the arrow comes down. Down left side is minus 1 equal to 2.5 kilonewton. Or we will calculate from here to here, right? You see from here to here. So we will take this arrow. This arrow comes down. This is right side. Right side arrow comes down is positive. Plus 4. Next, you see the arrow comes down. Down is positive. Plus 4. Next, you see arrow goes up. Upper right side is negative. Minus 5.5. 8 minus 5.5 equal to 2.5 kilonewton. Next, we will calculate shear force at E. From here to here, left side. From here to here is right side. Now we will calculate E to A. You see the A point, arrow goes up. Left side goes up is positive. Positive 3.5. Next, you see the arrow comes down. This is left side. Down is minus 1. You see this arrow comes down. Left side is minus 4. 3.5 minus 1 minus 4 is minus 5 equal to minus 1.5 kilonewton. Or now we will calculate E to B. This is right side. You see E to B is only 2 forces there. You see this force is comes down. This is right side, right? Comes down is positive. Plus 4. Next you see arrow goes up. This is right side. Right side arrow goes up is negative. Minus 5.5. 4 minus 5.5 is 1.5 kilonewton minus. Next we will calculate shear force between E and F. Next we will calculate shear force between E and F. E and F between means we will draw the midpoint of E and F. So from here to here is left side, from here to here is right side. Now we will calculate left side. You see the RA arrow goes up. Left side arrow goes up is positive 3.5. Next you see the arrow comes down. Left side arrow comes down is negative 1. Next also comes down is negative 4. Only 3 forces is there. 3.5 minus 5 equal to minus 1.5 kilonewton. Or now we will calculate right side. Right side you see arrow comes down. Right side is comes down is positive. Plus 4. You see the RB arrow goes up. Up is you see right side is negative. Minus 5.5 equal to minus 1.5 kilonewton. Next, we will calculate shear force between F and B. Calculate shear force between F and B. Between means we will draw midpoint of these two. From here to here we will calculate left side. From here to here is right side. You see the RA forces goes up. Up is positive left side. Plus 3.5. Next you see the C force. C force arrow comes down. Down is negative. -1. Next also comes down is negative -4. You see the F force arrow also comes down. Down is negative for left side. -4. Next you see any other force is there? Nothing is there. Only 4 forces. 3.5 -9 -5.5 kilonewton. Or now we will calculate right side. Right side only one force is there. You see the arrow goes up. Right side arrow goes up is negative. -5.5 kilonewton. Next we will calculate shear force at B. Shear force at B. This side is left side. This side is right side. First we will calculate right side. Right side you see the arrow goes up is negative. Negative is -5.5 kilonewton. Or from here to here, RA forces goes up. Goes up is positive. Plus 3.5. Next, this load is comes down. This is left side. Comes down is negative. -1. Next also comes down is -4. Next also comes down -4. 3.5. Add this 3, -1, -4, -4 is -9. Plus 3.5 -9 is -5.5 kilonewton. Next we will write it as shear force between C and D is equal to 2.5 kilonewton. Next, shear force at D is 2.5 kilonewton. E is -1.5 kilonewton. Next, shear force between E and F is -1.5 kilonewton. Between F and B is -5.5 kilonewton. Shear force at B is -5.5 kilonewton. Now we will draw shear force drawing. First point is 0. So we will point it here. Next, you see shear force between A and C. A and C is 3.5. So this is 3.5. From here to here is 3.5. A to C. Join this line also. This is 3.5. Next, between C and D. C and D is 2.5. So 2.5 is, here is 2.5. So here is also 2.5 between C and D. Now we will join the line from here. After that comes. Next, shear force at D. D is also 2.5. So this is also 2.5. This is also 2.5. Next, E. Shear force at E is -1.5. So E is here. Here is -1.5. Here is -1.5. Here is 2.5. Here is also 2.5. Here is 3.5. Next, shear force between E and F. E and F also -1.5. So the same only comes for here also -1.5. Next, shear force between F and B -5.5. Here is -5.5. So shear force at B is -5.5. Now we will join the line. This one comes UDL. UDL we will show this way. Point load is straight line. UVL will show parabola this way or this way. Next, this is point load straight line. So comes joins here. This is point load straight. So joins here. Ends with 0 only. 5.5, 5.5. This is negative. This whole thing is positive. This is shear force drawing. Next, we will see bending moment calculation. First, we will take bending moment at point A. Point A bending moment and point B bending moment is 0 only. What is moment formula? Moment is force into distance. RA force is 3.5, distance is 0. 3.5 into 0 is 0. Next, you see RB. RB force is 5.5, distance is 0. So 5.5 into 0 is 0. What is the bending moment definition? Algebraic sum of the moment of the forces to the left or right of the section taken about the section. So we will calculate right side and left side also. Both answers should be same only. First we will see bending moment rule. First rule. It goes clockwise is positive, anti-clockwise is positive. This is positive bending moment. This is left side, this is right side. Next we will see second rule. It goes anti-clockwise is negative, clockwise is negative. This is negative bending moment. Based on this rule only we will calculate bending moment calculation. Now we will calculate right side bending moment. You see the point, see the arrow comes down. You see from here to here. It goes clockwise. So clockwise is, you see, negative. Minus 1 into, what is the perpendicular distance is 1. Next, you see the arrow comes down only. You see from here to here is clockwise. Right side is negative. So minus 4 into perpendicular distance from here to here is 3. Next, we'll go for this force, F force. You see the arrow comes down from here to here is clockwise. You see right side is negative. So minus 4 into perpendicular distance. You see perpendicular distance is from here to here is 5. Next you see this arrow goes up. Up is, you see, from here to here. Anti-clockwise. You see anti-clockwise is positive for right side plus 5.5 into, from here to here calculate the perpendicular distance is 6 equal to 0. Minus 1 into 1 is minus 1. Minus 4 into 3 is minus 12. Minus 4 into 5 is plus 5.5 into 6 is 33 equal to 0. You add this 3, 33 minus 33 plus 33 is equal to 0. You see left side answer and right side answer is same only. Next we will calculate point B. So point B, you see this is point B is here. So this is right side, this whole thing is left side. Now we will calculate left side. Left side RA value from here to here. So you see the arrow goes this way. This way is, you see left side is positive. What is the force? Force is 3.5 plus 3.5. What is the distance from here to here is 6. Next you see this arrow goes this way. Anti-clockwise. Left side anti-clockwise is negative. Minus 1 into, from here to here, 5 perpendicular distance. Next, from here to here, arrow comes down. This is anti-clockwise. Anti-clockwise is negative. What is the perpendicular distance? 3. Minus 4 into 3. Next we will go for F force. You see this force arrow comes down. You see from here to here is anti-clockwise. Anti-clockwise direction, you see minus. Minus 4 into distance is 1. 3.5 into 6 is 21. Minus 1 into 5 is 5. Minus 3 fours are 12. Minus 4. 21. Add this 3. 12 plus 4 is 16. 16 plus 5 is 21. Plus 21 minus 21 is equal to 0. Next, we will calculate bending moment at point C. So this point we will calculate now. From here to here is left side, this side is right side. Now we will calculate left side. You see the RA arrow goes up. Left side arrow goes up is plus 3.5 into perpendicular distance is 1 equal to 3.5 kilonewton meter. Or next we will calculate from here to here. You see this arrow comes down. Right side, right? Arrow comes down is from here to here only we'll see. You see clockwise. You see the clockwise is negative. Minus 4 into perpendicular distance from here to C only we will see. 2. Next, we will take this arrow. You see arrow comes down from here to here is clockwise. Right side we are seeing. You see clockwise is negative 4 into perpendicular distance. You see from here to here perpendicular distance 4. Next you see RB arrow goes up is from here to here. This is anti-clockwise. So anti-clockwise is positive plus 5.5 into perpendicular distance is from here to here is 5. 4 2s are 8, 4 4s are 16 plus 5.5 into 5 is 27.5. This is also minus 8. Minus 8 minus 16 is minus 24 plus 27.5 equal to 3.5 kilonewton meter. Now we will calculate bending moment at point D. You see the arrow goes this way from here to here. This is clockwise. You see clockwise is positive. For left side 3.5 into perpendicular distance up to D is 2. Next you see the C point, arrow comes down from here to here is anti-clockwise. You see anti-clockwise is negative. Minus 1 into perpendicular distance is, you see, up to D only 1. So 3.5 into 2 is 7. Minus 1 is 6 kilonewton meter. Or now we will calculate right side. You see the arrow comes down from here to here. This is clockwise. You see clockwise right side is negative. Minus 4 into perpendicular distance up to D is 1. Next we will see this arrow comes down from here to here is clockwise. You see clockwise is negative. Minus 4 into perpendicular distance from here to here is 3. Next we will take this force arrow goes up is this way from here to here. This is anti-clockwise. Anti-clockwise you see positive 5.5 into from here to here distance is 4. Minus 4 into 1 is minus 4. Minus 4 into 3 is minus 12. Plus 5.5 into 4 is 22. Minus 16 plus 22 equal to plus 6 kilonewton meter. Next we will calculate shear force at point E. From here to here is left side, this side is right side. You see the arrow goes up from here to here. This is clockwise. Clockwise is positive 3.5 into perpendicular distance is from here to E, so 4. Next you see this arrow comes down from here to here is anti-clockwise up to E. Anti-clockwise is negative. Minus 1 into what is the perpendicular distance from here to here is 3. Next you see this arrow from here to here. This arrow goes anti-clockwise, that is minus 4 into perpendicular distance is 1. 3.5 into 4 is 14. Minus 1 into 3 is 3. Minus 4 into 1 is minus 4 equal to 14 minus 7 is 7 kilonewton meter. Next, or. Now we will calculate right side. Right side, you see only two forces is there. You see this force comes down from here to here. You see clockwise. So clockwise right side is negative. Minus 4 into perpendicular distance is 1. Next, you see this arrow goes up. You see this is anti-clockwise. Anti-clockwise is positive for right side. Plus 5.5 into perpendicular distance from here to here is 2. Minus 4 plus 5.5 into 2 is 11 equal to 7 kilonewton meter. Next we will calculate shear force at point F. From here to here we will calculate left side. This side is right side. You see the arrow goes up from here to here. This is clockwise. You see left side clockwise is positive. Plus 3.5 into perpendicular distance from here to F. So 5. Next, this arrow you see from here to here. This is anti-clockwise. Anti-clockwise left is negative minus 1 into what is the perpendicular distance? 4. Next, you see this arrow also anti-clockwise. Anti-clockwise is negative minus 4 into what is the perpendicular distance from here to here is 2. 3.5 into 5 is 17.5 minus 1 into 4 is 4. 4 2s are 8 equal to plus 5.5 kilonewton meter. Next we will calculate right side. You see right side only one force is there. The arrow goes up. Right side goes up is positive. You see 5.5 or right side also plus 5.5 kilonewton meter. Bending moment at point C is equal to 3.5 kilonewton meter. D is 6 kilonewton meter. E is 7 kilonewton meter. F is 5.5 kilonewton meter. Now we will draw bending moment drawing. You see A point is 0, B point also 0, C point is 3.5, D point is 6, E point is 7, F point is 5.5. Now we will join the line. This is parabola. Now join the line. This is C, A, D, E, F. This is B. Now we will calculate this point. You see, this point we don't know. So we need to calculate this point, X. Now we will take this one to calculate X value. This is X. This distance is 2.5. This distance is 1.5. So we will take this is as a 2.5. This is as a 1.5. What is this distance? This distance you see 2, right? From D to E is 2. So we will write this one as 2 minus X. Now we will calculate this one as a triangle proportionality method. X divided by 2.5 equal to 2 minus X divided by 1.5. You see here X divided by 2.5, 2 minus X by 1.5. Next we will cross this and this. 1.5 X is equal to 2 minus X into 2.5. So 1.5x is equal to 5 minus 2.5x. X goes one side. So 1.5x plus 2.5. X is equal to 5. You see here minus goes this side is plus. Next, 4x equal to 5, x is equal to 5 by 4 equal to 1.25 meter. Now we got this x value as 1.25 meter. Now we will calculate bending moment at this point from here to here. So this point we will take it as 1.25. We will calculate this value. Arrow goes up, left side is positive, plus 3.5 into, from this to this distance only we will calculate. So 1 plus 1 plus 1.25, 3.25. Next, we will take this force. This force arrow goes anti-clockwise. Anti-clockwise is negative. Minus 1 into, what is the perpendicular distance? 1 plus 1.25 is 2.25. Next, we will take this load. The load is 2 kilonewton meter, distance is 1.25. So minus 1.25 into load is 2 into 1.25 divided by 2. Now we will multiply 3.5 into 3.25 is 11.375. Next, minus 1 into 2.25 is minus 2.25. Next, multiply this 3 minus 1.5625 equal to 7.56 kilonewton meter. So this is 7.56. This is parabola. So you can draw this as a parabola curve. So this distance is 7.56 kilonewton meter. Thanks for watching this video.